Hello and welcome to another edition of Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I'm your host, Stuart Cording, the electronics reporter. Now, for years, the development process for electronics hardware has followed the same steps. With requirements defined, it's time to research possible components, develop the schematic, and start laying out prototype PCBs. Over time, many blocks establish themselves as reliable and are reused, but the level and manner of reuse are nowhere near as close to that of the software industry. So is this changing, and if so, how? We're also just 1 week away from Embedded World 2023, the premier trade fair for embedded system developers. After a few difficult years due to COVID, the event came back strongly in 2022 with great visitor numbers and plenty of exhibitors. So despite the growth in digital, why are such in-person events still so appealing? And how do you prepare for them? To find out more, my panel of experts for this episode are Tobias Pohl and Bettina Giemsa of Celus and Johann Wiesböck of the trade magazine Elektronik Praxis. So let me just bring our guests in here briefly. There's Bettina and Tobias. Hi Bettina, how are you?
Hello, good afternoon.
So can you just tell us briefly about yourself and what you do at Celus?
Yeah, okay. My name is Bettina, obviously. I've been in the tech B2B marketing world for about 20 years, and I just joined the Celus team last summer to run marketing.
Fantastic. And Tobias, welcome to the show. It's great to see you again. We saw each other at Electronica. For our audience, just give us an insight as to your role at Celus.
Sure. Thank you very much for having us on the show, Stuart. Great to be here. Quickly to me, I'm Tobias. I'm one of the founders of Celus, started the company originally about 5 years ago. And we're really all about allowing engineers all around the world design their circuit boards in the fastest possible way, get to components in the best way, and in the end, to schematics and circuit board prototypes like this one here in as little time as possible.
Great, super. Well, thanks very much. Now, our other guest, Johann, he will be on the show later. He'll be joining us about halfway through to talk a little bit more about his relationship with Embedded World. So thanks very much. I'm just going to take you out of the show for a second, and I shall bring you back in shortly, Tobias, for the next section.
Thank you.
So this episode is sponsored by, just bring that in there, is sponsored by WinSource. Founded in 1999, they are the largest online electronic component store in Asia. They offer a wide range of obsolete and commonly used electronics parts. It has for decades been recognised by third-party certifications and was bestowed with the Top Asia Pacific Distributors 2022 award by Source Today. Via WinSource, you can source over 1 million electronic components online, reducing your costs, taking advantage of same-day shipment and their 365-day warranty. To learn more, visit the win-source.net online store after the show. Now, I look fondly back at my years of designing lots and lots of different circuits, laying out the boards, searching for some components, ordering the PCs, and then building those first prototypes. And I hope that the questions I've prepared today cover many of the struggles you also face on a daily basis. However, this show is for you engineers out there struggling with your designs. So regardless of where you're watching, post your questions and comments during the show using the chat function on YouTube and LinkedIn, or via Twitter using hashtag ElectorEI, and we'll do our best to get answers or guide you to resources that might help. Super. Let's bring Tobias back into the fold. Hi there, Tobias. Great to have you on the show. Thanks ever so much for taking the time today to talk to us. Now, what I wanted to start with was, as I said in my introduction there, I think most engineers are very much used to how electronics is designed today. We sort of start with their requirements. We go out and search for some components which are going to be suitable for the design. We might even have some background history and we'll reuse that stuff. Then we develop a schematic, a PCB, and then we sort of iterate that design until it's in a state which is production ready. Is that also how you see the status quo today?
Yeah, that pretty much reflects what we see across most different projects. And if you think about it, that kind of makes sense, right? You need to know what you want to do. You need to start with requirements, with a functionality description of some sorts, even if it is just a whiteboard sketch. And then need to find your right components, go to your schematics, go to your layout. That sequence must be like this. Even though if you're realistic, it's rarely a sequence. It's a very common back and forth between all of these steps. And another observation that we have is that quite often PCB, for example, gets a lot of attention. I think because it's the final outcome. It also looks most exciting. But where statistically most spend the majority of the time is actually on the component selection and schematic stage. So that's what we see in most projects and what most time and effort in the end actually goes into.
So what sort of areas for optimization do you see in that process? It seems to make sense. It seems very clear. Everyone seems to know what is involved in it. So you know, why do we need to sort of remake this wheel?
I wouldn't even call it remaking the wheel. It's just that in that wheel there are a couple of opportunities, and we can go over them, that allow us to get more out of our engineering time. Basically, how can we get more value out of the same resource, if you will? And if we go through them step by step, in the very beginning, if you think of most requirement definitions, most functionality descriptions, you have different tools that support that. You have the most basic, a whiteboard sketch. You have PowerPoint slides. You have a Excel table. That's probably one of the most common things to do. You might even have a very advanced requirement management tools. But in any case, they're all about having, let's call it, human text being written by engineers and meant to be consumed by engineers. So it's a pure information management. It has no direct impact on your engineering tooling. And that's clearly a point that we can make use of, that we can bring your requirement and functionality description directly over into the engineering cycle. Another one is facilitating design reuse in a better way, allowing you to start with more of a platform approach, or allowing you to reuse certain circuits that, for example, the industry already provides in reference designs, in design templates, in application notes. Having easy access to as many of them as possible and finding what is perfect for your requirements is a point where we see a lot of opportunity for improvement. And probably arguably the biggest one that quite frankly was also triggered a bit out of personal frustration from my engineering days is really the data sheet. I really have an issue with data sheets. If you think about what a data sheet is, it's a engineer from a semiconductor company, from a component manufacturer who knows it all. Like, they designed that shit, they should know. And they dump all their information into a PDF data sheet for an engineer to read it and put it into their ECAD system again. That's, in my mind, that's madness. But that's status quo. And I think that's probably an area of maybe the biggest source of improvement, because it's just that broken to my mind.
I completely agree with you there. I used to work in chip design in the past, and that's exactly how the data sheet is made. This is literally, the information is dumped into a PDF. And yeah, I think actually this is going to be a topic for another show. I think we need to sit down with a quorum of engineers and figure out how we improve data sheets, because at the minute, like you say, it is quite a mess.
And it's not just time being wasted, which is an issue by itself, but it's also frustration. Like, I never came across an engineer who said, "I'm super excited for reading a data sheet." That's just not a thing.
I quite like data sheets.
Really?
But
like, really from the perspective
they are frustrating.
Right? I would also say so. I always it made me mad.
Yes, I totally agree with you. So that there's always something that comes up in the data sheet, and you go, Sorry, that just doesn't make any sense. So yeah, okay. Well, I'm going to note this. This is a good topic for the future. Maybe we need an IEEE standard or something for data sheets, like we have for
That would be cool.
Ethernet and things like that. So we love standards in our industry, don't we? So why not?
Yeah.
So so you've done a great job there, sort of describing some of the challenges and some of the things we can improve. So as you said, you founded Celus together with some friends, some colleagues. What is it that you're doing at Celus then to sort of tackle these challenges and make these things a reality in terms of improving the development process?
You could say we really start from how the process looks like today. So we're not reinventing the wheel. We're not breaking it apart and like it's ridiculous, but let's just say it. We wouldn't come up with the idea of starting with the layout and then working backwards to schematics. That doesn't make sense. So we take the process as is and make all steps connected with one another. And at each and every step, see our opportunities for simplifying it and for improving it with the help of automation and AI, for example. So if you think of, let's take maybe literally the circuit board that I brought with me. That's a small automotive battery management system. What you would in the classic process start out with is, let's say, your functionality sketch, your requirement definition. And that's the same with us. We have a part of our tool called the design canvas, where you, with functional blocks, sketch out the requirements of what you want to achieve. So you would say, I have 4 voltage levels that I need to measure with that type of accuracy in that voltage range. I have 2 temperature probes that I want to connect like this and be of that measurement technology in that measurement range, whatever it may be. You define your requirements. And now comes the core difference of what we do. We don't just take that as information to dump on an engineer's desk. We take that as the starting point for our automation, searching for circuits and components fitting these requirements over different abstraction levels. So you start from that high level of functionality you want to achieve. We take that down one step to find fitting circuits. We call those kubos. That's think of a reference design from a component manufacturer that could end up in a kubo. The most simple kubo probably would be a voltage divider, 2 resistors connected together. And that defines how components can create a functionality. And from that stage, we then trigger another search to the actual components. Let's make that voltage divider example again. Then from that, we would search for the 2 resistors. And that's really how our abstracted engineering flow works. And the core is automatically finding the right circuits, automatically finding the right components, and then export them as full-fledged schematic files to existing ECAD tools and create a initial PCB prototype. So like that board right here that I brought, that was a fully automated state. So from start to finish to get to a board like this takes about half an hour. So from an empty sketch to this board right here is about half an hour of engineering effort. And then you would hand over into the existing processes, basically.
So yeah, I think you've done a good job there, sort of explaining an overview. So would you be able to sort of go into a bit more detail as to sort of how that actually functions then in the tools that you provide? Because it's an online environment, isn't it?
Mm-hmm. So yes, as you said, we are 100% cloud-based software solution. You access our tools over the browser from whichever platform you want. And we also separate our platform into multiple different tools. The one I was just referring to is Celus Supernova. That's, you could say, like our flagship, the core tool that we talk about the most. That's where that design canvas I was speaking of is happening. And in that, imagine within a web application, a flow chart that you describe, and each and every of these blocks can have specifications and functionalities that you want to achieve. You would do that for the entire diagram. And then you can also add specifications for connections. So for us, a connection between 2 different blocks is not like a signal or a net in a schematic that is more abstract, that is more, I want those to be connected, however that works. You can then, if you care, you would then specify, I want from the temperature sensor to my microcontroller, the connection has to be I2C. So you would specify that. You would then still see one line for I2C, even though you would have SCL and SDA underneath. And with that, you specify what you want. And then we trigger that search out of every one of those blocks under consideration of requirements across the entire canvas. And that brings you to the Kubos. And from the Kubos, it's actually a quite mathematical connection to the component search underneath. So that then is like imagine like a search tree that is spanning out and then links you to the actual results that you need.
Okay, so so we've got this sort of this environment. I think it's very clever actually, because I see this actually in some other areas of engineering where we sort of we lose track of linking data to sort of functionality, and as you already described, we sit down with a design requirements document, we write what we plan to have, and then we race off and do something, and that link then typically gets lost, because you keep going back and you're changing the requirements when you remember to what it is you've actually done. So I think that's clever in that process, and the idea that the tool actually then suggests, as you say, sort of off the shelf blocks which fulfill the task. So temperature sensing, here's a range of different temperature sensing approaches for the temperature range you're talking about. But I think one of the challenges we often see with any technology is sort of traditional tenured engineers have a problem with change, and they sort of rarely accept this having design autonomy taken away from them. And I can see that being a concern, sort of, you're taking that some of those design choices away a bit. How easy is it for somebody who is very experienced and they know to a good degree what it is they want to do, and sort of could sketch it all out on the back of an envelope and it would work first time? How easy is it to take the suggestions the Celus environment is offering and then apply their knowledge to that and their experience to sort of tune it to their needs?
I can fully relate to that. That makes perfect sense. I also think you were choosing the perfect words for that. It's not design choice, it's design suggestion. So we make a suggestion of what we think would fit best for that requirement, that functionality. But what we always say, the engineer, our users, are always in the driver's seat. So you can take that suggestion and run with it. The more experienced you are, the more likely it is that you will have an opinion on that. And then we give all compatible options that we see and allow you to choose. So that's the first point where you can influence and in the end override every decision we make. And that's fine, because you probably care about a certain circuit being done a certain way for a part of your design. And that's really what we're trying to achieve. We're trying to allow engineers to focus on what they care about and automate what just has to be done. And that is, from our perspective, the most efficient use of time. But it gets even further, because an even better use of your time is if you cannot just apply your knowledge for the project at hand, but for all other projects that go on in your company, for example. So if you create a fantastic circuit for a power supply, for example, that is really hard. Like, that is hardcore engineering to get a DC-DC converter tuned out nicely. It would be great if your colleague that is working on a similar project 2 months later wouldn't have to do the same from scratch and only find out that you do that while chatting at the coffee machine. That's not a scalable process. And that's where the Kubo comes in. The Kubo is, you could say, stored engineering know-how that then gets reused. And that's what we see more of in an analogy to how it is in the software world. A software developer today also wouldn't say, man, these high-level programming languages, they all take away my decisions. They technically do, like, you're not assigning CPU instructions anymore, but that didn't make the value of skilled developers less important. You could maybe even argue the opposite, actually. And I think the same will happen in the electronic sphere. We will never, that's at least my hypothesis, we will never reach a point where you're like, let automation take care of all of that and we are not needed anymore. That won't happen. I think that is the same change that happened in IC design with automation or in software development with compilers. I think the same will happen in electronics, where it's just a shift in workload and in where you invest time, and not in are you important or not. That I think won't change.
One of the things that just occurred to me as you were talking there, is obviously Celus. You still call yourself a startup, although you've been around quite a few years now. And people watching who haven't heard of you before may be sort of interested to know sort of how mature is this environment. If we've talked about simple things, we've talked about say doing a temperature sensor, which is most engineers could develop on their own without any effort at all. But when it comes to something more complicated, such as wireless interfaces or radar or graphic user interfaces and touch interfaces and things like that, are they also elements that your environment recognizes and has suggestions for?
Yeah, that definitely works. So in terms of component selection, circuit selection, so these QUBOs, and also in terms of schematic design, we have quite little complexity limitations by now. We've done designs with big FPGAs, thousands of nets. So we can take that quite far already. While at the same time, let's be honest and straight here, I would definitely still call us a startup, and we are cracking a very complex nut. So that is nothing that comes overnight. We by now have quite a big team working on that technology, but that is still something we're heavily improving on. We need to put a lot more work in that. We are far from done. So there is still a lot that needs to go into that.
Yeah. Now, one of the other things as a sort of concern I would see is that teams, I remember when I first got my hands on some PCB design software, we spent a lot of time defining our schematic symbols, getting the footprints organized, getting the documentation in that EDA tool in place so that we could all use and share knowledge at that simple level of component exists and footprint exists that we can solder. So if someone wants to consider transitioning from whatever they use today to your environment, are those things that they can import? Is there some sort of standard interface for that, or is there sort of limitations?
I'll give you probably now a very similar answer to before. If you care, yes. If you don't care, you don't have to. And that's really the entire methodology that we built into our tool. If you care about your library, about your footprints, about your symbols being exactly like you want them, then you can integrate them into the library. That's a separate tool that we have that's called Celus Orbit. That's, you could say, the foundation that Supernova is built on, where all the component and QUBO information lies on. There you could store all your components, manage your entire library and your entire component information, including footprints, symbols, all types of component data. Also on that circuit level, these QUBOs can be stored, uploaded, managed in there. Usual input sources there would be the established ECAD tools. So let's say you have a circuit in Altium Designer and you want to bring that over into our system to then be able to access it with the automation and the end hour export. That works completely fine. At the same time, if you, let's say, you just want to access standard library of footprints, you also can do that. So that it's always like a hybrid approach where, as I said in the beginning, if you care, invest the time and do it. If you don't care, automation should take over. That's kind of the mental model.
Super. Yeah, I think it's good to know that it is possible, because I mean, some people work with some very esoteric chips, and sometimes they're designed for them, aren't they, as well? Some there's I've worked on airbag chips only go to one customer, so you need that flexibility there quite often, I guess.
And there, if you sorry for jumping in there, if you think of large companies, complex projects, we never saw it differently. Like we have some very large customers that we work with. They manage their library. That's reality of engineering.
Yeah, no, exactly. Super. So then I was going to come back to the point of the environment. As you've already stated, it's a cloud environment, and especially here in Germany, I'm sure you get a lot of pushback on simply the fact that it is in the cloud. Where's the data stored? How are my projects secured and separated so that nobody else can access them? How can I even maybe limit access to a project to only certain employees, because only they should have access to a particular project? How does all that work?
Mm-hmm. I see kind of two parts of that question. One is, let's call it access control from different teams and different team members that you have. That can be easily set up to the individual requirements of every company. It might be that you also have different roles. So let's say you have a library manager that can approve changes in your library, and you have a library engineer that can create new components, and you have a hardware engineering team that uses them for their engineering projects. That can be all set up, and then you have a quite big workflow engine in the background that can handle these, let's say, change requests, can handle how you pull information from one part of the library, and kind of all of that within our environment. We can, in some specific cases, also pull information from other parts. At the same time, that is, and that's what I meant with part of the question, that's all, let's say, within the safe space of our environment. If you're asking about that very thing, whether that cloud environment is safe for people to access, that actually questions about that got even a lot less, because there are not that many companies left that don't have cloud tools. Like think of Google Docs, Microsoft Office 365. All of these tools are becoming pretty normal, and that's why these questions also come up less often. But to answer that, we are hosting for a German customer. We would be hosting entirely from AWS in Frankfurt. Your data would be stored in Germany, would be handled in Germany, would not leave Germany. We have a very complex security system in the background that would protect your IP and also make sure that it stays within your company boundaries, for example. So that is a very robust system in the background for handling that. If we link back to what we had with a very large international organization, then we have a content delivery network that allows you to access our platform from all places in the world. We can ensure pretty much the same uptime and response rates from New Zealand as from Alaska. So that would also work.
So that's I think that's great news. That's one of the sort of the biggest challenges, I think, for all online-based platforms, and that's something a lot of companies struggle with internally all the time. So it's good to hear that is implemented and has been securely and robustly examined in that manner. Now, I've got one more question for you before we move on to the next section of our show. I've been following you on LinkedIn, for example, and seen that there's been some requests for beta testers for a new product you're currently testing. I was wondering, could you tell us a little bit more about what it is you're testing, what the beta testers are looking at, and are you still accepting more beta testers for that program?
So that is definitely something to be very excited about heading into Embedded World, because at Embedded World is where we want to actually kick it off and launch the first beta platform of our new tool. I can, and I think we never announced that anywhere else. I can maybe even announce that here that tool will be called Celus Open Space. So a new environment, a new part of our offering. And yes, we indeed still accept beta testers to the program. Everyone can sign up for that. That's a major new part of our platform.
Well, thanks ever so much. That's an Engineering Insights first to have a new product launched on the show. So thank you so much for allowing us to be the first to share that with the audience. It's great news. We wish you all the best with that. We'll be talking about Embedded World shortly and be sharing your stand details as well at the end of the show. So we'll move on to our competition and our giveaway that we do each show, and say thank you ever so much to Tobias. We'll hang in there. We will be back with you shortly.
Thank you very much, Stuart.
So now it's giveaway time, and now I need to find the giveaway as well. There we go. That's our giveaway. Yes, so giveaway time. Firstly, congratulations are in order to last episode's winner, Theo. Your Wireless IoT Shield Kit is on its way. And to extend our thanks to you as loyal Engineering Insights viewers, this episode I have some good old-fashioned embedded boards up for grabs. To be precise, they're 3 Raspberry Pi Pico RP2040Ws. The RP2040 boasts dual Cortex M0 processors, and these boards include an Infineon 2.4 GHz radio transceiver and integrated onboard antenna, and that enables you to connect them to a Wi-Fi router and maybe explore a little bit of the world of Internet of Things. For your chance to win, simply visit the link shown below and enter the keyword prototyping. That's the keyword prototyping with your entry. We wish you all the best. Good luck. So, as I said before, we also have our extra guest with us now. Join us on the show. There is Johann. I'm just going to take that Raspberry Pi out of your face there. Good to see you, Johann. How are you?
Good to see you. Very well. Hi, Stuart.
Thanks ever so much for joining us, because obviously you've taken time out for your trip to the mountains to join us in the show today. Perhaps you could just say in your words, in your own words, what you do and sort of your background in the world of the electronics industry.
So in a moment here in South Tyrol for skiing, but from next week on, I'm back in my real business. It's Elektronik Praxis. I'm the editor-in-chief of Elektronik Praxis. And I'm long around in the industry. I always had this job as an electronics editor. I love this. It's a famous industry, and it's always good to see new people and to learn about new technologies. And the Elektronik Praxis is writing about this in all channels, print, digital, and events, and so on. And I love events.
Yes, I know, because we spent a lot of time at them together and moderated them together as well, and it's always a pleasure to spend time with you and on those events and shows. So one of the reasons we've brought you onto the show today is that you have quite a personal link to Embedded World, the exhibition that we visit today. Could you tell us a little bit more about how the Embedded World we see today came about initially, and who brought it into being, and what you were trying to do at the time?
Yeah, so it was in the early 90s. I was editor-in-chief of Design and Electronic, and we run developer conferences about certain microcontrollers. One I can remember was RISC versus CISC, so Intel against the rest of the world kind of thing. So this was a big success. And one day I had the idea to do a big event with all microcontroller providers, with all tool companies, and this was too big for a conference. So the idea to do an embedded show was born, and I had the concern that the Americans come to Europe, because there was the Embedded Systems Conference around in the early 90s, and we had no similar show. So I asked my boss, can I do a embedded show? And he said, oh, this is a new kind of business model. Our company is not so well doing in a moment. Please find somebody and do the conference by yourself. So this was the kick for me. I found a person. This was Ludwig Trebinger, and 2 years later we started the Embedded Systems Conference. And a key point was in those years, Motorola was the player number one in the processor microcontroller field, and we asked them first to whether they want to join this event, and they said, "Hey, great idea. Germany is a big market. We will support you," and the rest was easy.
It's always good to have that lead supporter, that lead champion, isn't it, to get these things over the line and get them started. So,
definitely.
So the Embedded Systems Conference is how it all started. Were you able then from the beginning then to get an event out every year afterwards, and how did that sort of evolve over the years?
Yeah, it was. We started in 1995 in Sindelfingen. This is the place where all electronic shows except the Electronica started. The SPS show, the SMT show, everything starts in Sindelfingen, and then nobody wants to go to Stuttgart, and then the one of the few options is Nürnberg. So, but we did the same way later. But in the beginning, we had 105 exhibitors and 4,500 visitors, and this was a big success. Everybody was happy. All our supporters said, "Hey, great job." And we saw that the need for this event, and then we could start from zero to maximum from the beginning, and then we repeated every year. And 1998, I left the company and went to Vogel, and Ludwig Trebinger, the owner, sold the show a few years later to another company, and then the name changed to Embedded World, but it stayed on the same place and the same concept, and this was growing statically up to the size we have now.
In your opinion, what role does an event like this play in the context of our industry? Why is it so important? Why do we need it, and why do people keep coming back every year?
I think it's an important driver for our industrial field, also for automotive and the other sectors we have in Germany. But the biggest part is industrial control, and all applications are different, are causing new questions and problems, and it's the simplest way, if you know what you want to do and if you have started, to meet the experts from the industry and to make an interaction with them on a personal level. So this is a different to now to digital events. In digital events, you can learn a lot, you can hear a lot, but to build up a relation with the experts from suppliers and also from other companies, therefore is a live event the best solution. And I think this effect is still around and the key. I can see it from other events. We have a big software conference, and everybody was happy last December that we are back, and we had more attendees than before. And you could see that Elektronika was pretty much back to 100%. And everybody loved to be there, and business was great. And I expect the same for the Embedded show now.
I totally agree. I'm so excited about next week. I don't think it would matter if I got ill or anything would happen. The adrenaline would just push. The adrenaline would push me through all 3 days without any issue whatsoever. On that note, I'm going to bring in Bettina into the group as well. Hi, Bettina. Thanks for hanging in there for us. Now, what I wanted to ask you was, you're responsible for the marketing side at Celus, and obviously, as Johann just mentioned, digital is massive. Before the show, we were talking about social media and how digital has changed things, and how you make the most of that. But a trade fair is very expensive, but there's things you can do there that you can't do in digital, aren't there? So how does it work for you in your marketing mix?
Yeah, let me pick up on what Johann just said. It is, I think it totally agree with him. It is about the people and the relationships and the trust building. You build relationships at a trade show. When you think about a couple of decades ago, people, if you were in tech and you wanted to learn about new technologies, you would go to a trade show and really learn about all the products, go from booth to booth, and get all the paperwork in your goodie bag and take that home and review. Today, you're getting all that information really easily available on the internet, and the focus of the trade show is less on learning about new products, because you already know about most of those products, but you go to the show to meet those people. And I think it's like on the internet, yes, you can order like a $15 music app subscription on the internet. That's what you do, but there's no risk associated. But if you need a B2B or technical application that can cost like couple thousands for a license per year, then you really want to trust. You want to know who you are dealing with. You want to like build your relationship, understand if the use case is really a fit, and if the people can support you along your journey. And I think that's the invaluable aspect of a trade show. And yes, they are expensive, but so you have to make the most of it. And I've actually prepared a slide. If you want to bring that up, yeah. I can give my 2 cents on some of the points. And as I said, it's about the people, but you have to make sure that you have like clear expectations and goals. Like you may not be able to like meet your metrics and come home with a bag of leads that turn immediately into revenue. But there's so much you can do during those trade shows that will be very, very valuable in the long run. I think that the most important thing is you have to define and communicate your message. And it's like, because people can get like all this information ahead of time, that you have to come with your best message in order to promote your presence. And with all the exhibitors and attendees in there, we're all in this together. The trade show can only be successful if everybody is going. And yes, it is expensive for the exhibitors to have a booth. It's expensive for the companies who send their attendees, because those people will be away from their desks. So they better bring some value home. And this is why everybody needs to come up with some decent plannings. And so we want good attendance, and we want to arrange meetings. I think the best value for us is like being able to like talk about what we plan on doing up front, invite our contacts, and then make great meetings, build our relationships, answer questions. And for this, it's just important to have the right team on site, so that your experts really enjoy that type of relationship building. Somebody may be a super tech expert for your product, but he may not enjoy being with people. So you need to have the right team on site to make the most of it. And then definitely the last thing that is sometimes forgotten is like the follow-up. You can have like really good contacts at the show, but if you then don't follow up with the right information and continue to build your relationship, well, that will be a bad experience.
I totally agree. I remember going to my first trade fair. It was actually Elektronik, and I was super excited, this opportunity to sort of meet all of these people. But one of the interesting things was one of the guys who was there, who'd done hundreds of trade shows and been with the company for decades. He was saying, like, you need to balance your expectations. If you're going to a trade show thinking you're going to win a huge amount of business all of a sudden, that's probably the wrong expectation. If you're that minded, then everybody has to ask, what is it you've been doing then for the other 51 weeks of the year? You know, it has to be considered as part of promotion, part of working with your community, and that sort of thing, doesn't it? So how do you go about in your team sort of preparing the people for the event? We often used to do a chat before on the day, of course, just to tell everyone where everything is and who's responsible for what. But what's your process?
So basically, I mean, Toby already mentioned we have that big release coming up. So that is our big message for next week. And we've been talking about this at length. Like all our team, our sales reps, our AEs, they all have been working on making this release happen for weeks and months now, and they're all excited to go and talk about it and make the first public demo. And so we've been really closely aligned as to, okay, where do we stand? What do we want to show? And then we have our team has prepared the marketing, the materials, and the demos and slides for that. And we have been like always talking about this in context of the release, in context of what is coming up. We have been like, from a pure marketing side, we've been doing like blog posts, we've been like sending the message across social media channels, and that it all connects. I don't see like a trade show as one thing that happens as a singular event. I see all our marketing activities to be connected and combined.
Yeah, I agree. I think it's important to sort of bring all these things together, isn't it? Johann, you've been in the industry for decades. So how have you seen sort of like the way, how have we managed to merge together an in-person event like a trade fair well with the new digital channels like social media and websites and LinkedIn? Are we doing a good job there, do you think, or is there still more to be done?
I think the industry is doing a good job. Bettina mentioned it. You have to prepare the show. The visitors are prepared. They know what's available, what's possible, and I think it's the combination to use all channels in a clever sense, to work together to get hold of these design engineers who are the most interested animal in this industry, to attract him or her to come to the booth to learn about technology, and having a good message, as Bettina said, is very important. And this is not the message we are the best, we are the greatest. This is a message, we have the solution, we understand your problems, and we have the tools you need, and not so saying I can help you with everything. Say we are the expert for this and that. I want to add to what Bettina said in the beginning is the trust. I always tell people when we talk about this question, when an engineer comes to the booth and talks to the expert, he needs or she needs time to trust him or her. And then if after this, if you say, okay, this is a good person, I trust her, I trust him, then he would say, okay, we have a problem, we can't solve it. We work half year on this and we couldn't solve it. We are too stupid or whatever, we use the wrong things. Please, can you help me? And he never will, or she never will say this on a conference, on a digital way, that somebody recorded. So
exactly,
this needs the personal channel between us and them, and then it's easy, and then they like you, and then they stay with you, and then it's easy to do the follow-up. You told me you have a problem, or you're starting a new product. Do you need more from us? And then it's a natural way to communicate.
Yeah, and the one thing I would like to add is that I think at Embedded World they are doing really good job at pulling in or targeting to the audience, different audiences. Like we have there's this women get together for women in tech. By the way, happy Women's Day.
Exactly.
And then there is on the 16th there's a student day, and I think that is very important. Like bringing in the different audience and flavors together, and that is important for building the future of the event as it is progressing with our market and society.
Yeah, no, I agree entirely. I think the forum to bring the women in our industry together, I thought was a great thing. I didn't realise that was going to be addressed, and I think it's great that that's been highlighted. And I've actually been in working with the exhibitors. Exhibition centre separately to support them with the student day. So, and that's actually been very interesting to think about how my career started and how do we sell this career, this fantastic industry, in my opinion, to the next generation of engineers who are at the minute finishing their qualifications and thinking about what to do next. Bettina, one of the things I wanted to ask you, having just done Electronica, what do you think is the difference between Electronica and Embedded World, and would you use these trade fairs differently for Celus, or is it just we try more or less do the same thing each time?
Well, We are learning at every event, and with trade shows at every event something can go wrong, and you always find something you can improve. Actually, Elektronika, because we already mentioned we are still a startup, and going to a trade show is a massive undertaking for us, and it costs it takes some of my marketing budget. And at Elektronika, that was our first official standalone booth outside of any startup program, and it was one of those turnkey booths, relatively small, and we were flooded with interested visitors, and we were so happy and with the success that we said, okay, at Embedded World, we're going for a little bigger booth, and actually we doubled up our size. We invested a little bit more money to make it more shiny and representative. And but on the other hand, we were doing some promotional activities ahead of time that were running a little bit, that were just running differently for Elektronika. Now, for example, we invited people to get a ticket voucher. We had massive number of requests for Elektronika, and hardly nobody is asking for free tickets for Embedded World. But at the same time, we are making a super number of customer appointments. So you never know. Every event is different, and I think it's not necessarily the same people going to one event and then the other one a couple of months later. And the market is big enough for more than one successful event. So we are looking forward to it, and we are very excited for next week.
Me too. I'm going to bring Tobias in now as we're coming into the last 10 minutes of the show. Thanks for staying there, Tobias. During this section, I tried to bring in some questions from the audience and direct them to appropriate people as well. One of the ones that came in was actually from our friend Theo Mulder. I'm just going to pull that up onto the screen. I think it's related to the discussion we had at the beginning with you, Tobias. He says there's a lot of integration going on into dedicated chips, so sort of more specialized circuits, and there's then only a few vendors to choose from. And so almost what we're saying is there's almost no need to search for components anymore. It's getting a little bit sort of like that there's a chip for almost every situation. Do you see it that way as well, or is there still a lot of searching and component selection required today?
I would say that it's quite balanced. On the one hand, that integration effort leads to less components, obviously. You bring multiple different chips into one. That, as the comment said, reduces the amount of components you need to search for. So that is definitely true. That also, you can say, reduce the amount of search cycles that our tool needs to make, and with that, you basically the need for the search will go down. At the same time, and the question is whether that is balanced. Maybe it is even unbalanced to the increasing the need, and that is usually these heavily integrated chips are more complex to handle, and that makes it harder to get your design done. And that makes the need for more of a system engineering approach for modularizing part of your design more important. That helps us again. So I would say that these are probably fairly balanced, and one pulling in the one direction, one in the other. Another question in that direction that we get a lot is, won't at some point everything go into the actual chip and you have one die to do everything for the entire circuit board? I'm quite sure that this won't happen, because physics will be in the way of us. Let's make one extreme example. Building a big capacitor on a die, will that ever financially make sense? Probably not. So I think that balance will probably always exist in some way.
Super, yeah, thank you. I think I agree with you. I don't think we're going to see a one-size-fits-all anything. One of the things I think we're going to see probably more of is more system on modules, sort of small Arduino-type boards where there's a microcontroller and appropriate power converters and appropriate transceivers for things like RS-232 and CAN and USB available. So you become a bit more sort of modular at that level. But I think there's limits in semiconductors because of the cost of developing them. Johann, I don't know how it's been for you the last few weeks. I think my Embedded World calendar was definitely full to capacity with appointments about 3 weeks ago, and I could have filled it twice more since. What are you excited about with Embedded World this year?
Yes. On the one hand, we had, I think, so many invitations than never before. So all companies are very active, inviting us to one-to-one meetings, so some press conferences. And on the other hand, we want to visit our good customers and also new companies, startups, to see them. And therefore, I think the whole team is there, except the newsletter editors. They are switching. One day is the one, another the other one. But the rest of the team will be minimum 2 days on the show, and the editors who are responsible for microcontrollers, for software, and me personally, we are the whole time there. So and this loads me, and I think everybody else loads me up with information, with new contacts, and with new trends. And this is a important effect for me as an editor. To hear on my personal feeling is we will have a very good show, because what's happened before the show is normally also a number for the show itself.
Yeah, it's exciting. Well, we'll be comparing notes, I think, afterwards. We'll probably have to meet up for a beer and chat about what our favourites were.
Yeah, hopefully you can squeeze in a visit at our booth as well, Johann.
Exactly. Yes,
I will do it, definitely.
I'm very excited, actually, because I like I said at the beginning, we dropped by your booth at Elektronika, and I'm excited to see what you've prepared for us at Embedded World. And it's one of the things I actually do when I go around the trade fairs. Sometimes I take photos of stands, which for me make no sense whatsoever. And you wonder, you spent so much money, and I look at your stand, and I cannot tell from your stand what it is you do, and that goes back to Johann's point. You need to have a clear message. You need to be able to express very simply what it is you do, and not try to be everything for everybody, I think. So yeah, we'll be looking forward to that. Bettina, now earlier you mentioned that today is Women's Day.
Yes.
What's your opinion on sort of like women in technology businesses? We're continuously told that we don't have enough female participation. I would wholeheartedly agree with that. I don't believe we've got the balance right. What I do see is that we definitely see more women in administration roles in semiconductor industries, in technology businesses, and also in sort of the communications marketing. So that's where I see women more often, less so in the actual engineering. What's your feeling? Are we doing enough, or what could change?
Oh, I think the big change needs to happen in the schools. Like, I've been terribly bad at math. I have somewhat moved into the tech world through my marketing education, and I've stayed in tech ever since, and I really enjoy it. And I've often regretted. Well, I'm always struck in awe when I see a woman doing coding or designing or engineering things, that I wished I could do that. But now I have a 16-year-old daughter who has been doing good at math for some time, then struggling, and it all depends a little bit on the way it's being taught. I think everybody can understand math and technical concepts if the education and the teaching is good enough. And I think it's when I'm seeing what has happened, like, of course, with COVID, that was a special situation, but I think even now that we are past that, I think we need a lot of change on the educational side. And it's not about women cannot do this. Women can do this very well, but they may have to be taught in a different way, because we tick differently, we think differently, we maybe here and there more emotional than others, but if we embrace something, we do it fully, and we just have to get hooked on somehow.
Exactly. I think the point you raised there about the difference, that there are obviously some key differences between the way men and women react and work. But I think we've lost Johann there briefly. I'll try and bring him back in. There we go. Sorry about that. And that's why I think it's important that we have both sides, because you need both opinions and this broad range of opinions when developing engineering solutions. So yeah, I think schools is a good place to look. And we'll see how that develops. So I think Girls' Day and Boys' Day is coming up soon as well. So that's an opportunity as well to go out there and spread the word a little more. I was actually not that great at maths at certain points during my education. I still became an engineer somehow or other. So there is hope for everybody. Good. Well, I'd like to thank everybody for participating. We do have one last comment from a LinkedIn user. And they say, we're looking forward to welcome you all next week at Embedded World, and we will visit you at your booth, Bettina and Tobias. Unfortunately, I don't know who that is, but to make sure they find their way to your booth, it's Hall 4, stand 209, I think. Is that right?
4209, yep.
Yep, super. So thank you, LinkedIn user number 12754. They'll be looking forward to seeing you there, and we'll take you through, and maybe whoever you are, you'd like to be a beta tester, so that's your opportunity there. Thank you ever so much. Exactly.
And you'll find the ad.
Exactly, Celus.io as well. And if you don't have a free ticket yet, I think one of the reasons nobody needs it for your free tickets.
We have some.
There are so many out there. I think 20 different codes flying around. So it's not a reflection of not wanting to use yours. It's probably that people already have one already from probably from Johann's magazine. I think you have some printed in your magazine as well on various advertisements and things. So super. Well, thank you ever so much for everybody participating here today. You all, I'm just going to take you out of the show now as I wrap up. But really appreciate the insights that you've shared with us all today. Thanks you.
For having us.
Bye. Have a great show.
Bye. Bye.
Thank you. Bye.
So there we have it. In the world of engineering, it's very easy to keep doing what works because, quite simply, it works. But Robert Holden's book says shift happens. Engineers are changing, as are the demands that are placed upon them. Development platforms like that provided by Celus don't just simplify the development process, they also have the power to improve creativity and explore options that we'd never think of in isolation. And this leads us nicely to Embedded World. We go there precisely to be better informed, share ideas, and discover the latest technologies. Even in this digital age, trade fairs offer us the chance to press the flesh, talk one-on-one with experts, and see engineering in action. I think our industry would be much worse off without such events, and I can't wait to explore the halls next week. Thanks to my experts Tobias Pohl and Bettina Giemsa of Celus and Johann Wiesböck of the trade magazine Elektronik Praxis. You've delivered us with some outstanding engineering insights. So that wraps it up for today. Elektor will be at Embedded World next week reporting on the latest developments, because on the 14th of March we'll repeat our successful live mashup show that we did at Electronica, and I will be joining up with Jens from Lab Talk from Elektor to share the best of what we've seen on day one. If you're going to the show, don't forget to drop by Hall 4A, that's the new one at the front near the entrance, stand 646, and say hello to the team. And to keep you abreast of other industry trends that occur between exhibitions, don't forget to take a look at our Newsbite show which goes out monthly in a little 15-minute show. Please subscribe to Elektor TV Industry on YouTube and share our videos on whatever platforms you use, or drop by the website at elektormagazine.com/EEI to see the topics for future shows. Finally, if you'd like to join me as a guest, write me an email, drop me a tweet, or reach out to me, Stuart Cording, on LinkedIn. Thanks for joining, stay in touch, and don't forget to keep asking your engineering questions.